Hey Course 1, it's Miss Bloodworth or Mrs. Alt now. I just wanted to go over some adding and subtracting fractions rules. That way if you're stuck at home trying to do your homework, you have a little bit of direction on how we do this. So our essential question for the day was, how do I add and subtract fractions? And on the take-home paper that I gave you for your note-taking, I have all the rules listed out for you. Our first rule with adding and subtracting fractions is we want to find the least common multiple. Parents, if you don't know what that means, I will go over that in just a moment, but the kids should know what that means because we've been going over it for a couple weeks now. The second thing is we must rename each fraction. The third rule is that we add and subtract the numerator, leaving the denominator the same. And our final step is to simplify. If those rules don't make any sense to you right now, that's okay. I will go over that in just one moment as I show you an example to go with it. So we have our first example here. It's problem number 1 on our worksheet, which we went over today as a class. So we have these two numbers here. It says 2/3 plus 3/4, okay? But the first thing I had students do today was I had them notice, what do you notice about the bottom denominators? The denominator is always the number on the bottom half of your fraction, and the numerator is always the number on the top half of your fraction. So I had them point out that both of these numbers are different. And when you're adding and subtracting fractions, you cannot add fractions with different denominators. You just can't do it. So what we have to do then is to find our least common multiple. And if they match, we add straight across, no problem. But if they're different, we need to find the least common multiple to get them to match. And so when we do that, when we do that, we have to come over here. I'm going to show you how I did this. So we had our numbers 2/3 and 3/4. So I'm just going to write that up here. 2/3 at the top plus 3/4. And so I have to think of all of my least common multiple facts. So if I come over to the side here and I'm going to focus on just the 2/3 for right now, okay? So I'm just going to focus on this guy right here. I'm going to write out all the multiples for the number 3, okay? So I know I have 3, because 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, and I'm going to stop right there, okay? And then when I come over to this next side, I have 3/4, okay? So I'm going to write out my multiples for our denominator 4. So I have 4 times 1 is 4, 4 times 2 is 8, and 4 times 4 is, 4 times 3 is 12, and then 4 times 4 is 16. So what we're looking for is the number that both of the numbers intersect by. So if I come back over here, I know that there's a 12 on this side, and I know that there's a 12 on that side, which tells me our least common multiple for those numbers is actually going to be the number 12. So after that, I know which numbers I need to be multiplying by. So I'm going to come back over here to the 2/3 number, and I'm going to multiply, I'm going to take 2/3, and I'm going to multiply it by 4 so that I can get the common denominator of 12. So I have 2/3 times 4. So I have 2 times 4, which will equal 8, because we multiply it to the top and the bottom. 3 times 4, which will equal 12. And I keep this as my new number right here, okay? And I'll actually rewrite it down at the bottom right here so that I don't forget my new number, okay? So I have 8/12 as my new number, and I'm going to carry down that sign from the top right up here, okay? So I have that. And then over here, I have 3/4, which I have here in the orange. So I'm going to go 3/4 times, and I have to multiply it by 3 because I know that 3 will give me that common bottom denominator of 12. So if I go 3 times 3, that'll give me 9 on the top. 3 times 4 is going to give me 12 at the bottom. and I'm going to circle it because this is now my new number that we're working with. And I'm going to come down here and write it like this, okay? So we have 8 twelfths plus 9 twelfths. So if we just add straight across without even thinking about it, we're going to get 8 plus 9, which we all know, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we're going to get 17 over 12. Sorry, that's a really bad number. So 17 over 12 is going to be our answer. But if my students know, our last rule was to simplify. And so when we simplify, we have to divide, basically, is what we're doing. So what I'm going to do is I'm going to create a new page. I'm going to show you how we divide this to simplify it. So our last number was 17 over 12. And from there, what I'm going to do is I'm going to just divide like this. So 12, 17. So 12 goes into 17 one time. After that, I subtract 12 and I get the remainder 5. So my new answer will be 1 and 5 twelfths, because I have to make sure that all these numbers match up in this order. The number on top will then become my whole number, which is right here. The number that's on the bottom, otherwise known as the remainder, will be right here, 5, which will be my numerator now. And then my denominator will be the number that I was dividing by. So I have 12 right here and then 12 right there. So my whole new answer should be 1 and 5 twelfths. Okay, so that's just one example of how to add fractions. But something I talked to my kids about earlier too is that the same rules for adding apply when we're subtracting fractions. So that's really good news. Whew, yay! So I had the students practice this problem on their desks, where I had them try 5/8 minus 1/12. And so if you'd like to go ahead and give that a try by yourself, it'd be a really good time to practice. And if you want to pause the video while you're practicing and hit play, I will show you then how to get that answer. All right, let's go over this answer. So our problem was 5/8 minus 1/12. First step is always to find the least common multiple. I know that if I list out my multiples for 8 and 12, that the least common multiple is going to be 24. So I have to rename each fraction to get our denominators to match so that we can subtract. So what I did was I multiplied 5/8 by 3. 5 times 3 is 15. 8 times 3 is 24. And over here, the 1/12 number, I had to multiply 1/12 by 2 to get 2 on top and 24 on the bottom. After I got my new numbers, I had to subtract the numerator and leave the denominators the same. So I did 15 minus 2, which would equal 13, and 24 minus 24 when using fractions would stay 24. So your answer for that one should be 13 over 24ths. So that is, those are two examples of adding and subtracting fractions that we went over today in class. But then we went over something called mixed numbers, adding and subtracting with mixed numbers. This is probably where most of the confusion is coming from the students today, because it is a little bit more of a higher level thinking task, but we're going to go over it anyway. So with mixed numbers being added and subtracted, I have a simple problem right here just for everyone to try. We have 2 and 1/5 adding 1 and 3/5. Okay, so the way this works is that if the denominators are the same, you can go ahead and add straight across. But you can't just add, like some students today were combining the numbers in various ways. I would advise you not from doing that, because the whole number is separate from the fraction here. I mean, not completely separate because it's 2 1/5, but you're not supposed to combine them all together. Like I should not be combining all these numbers to make one giant jumbo of a number. What you want to do is you look at these all separately. That's why I color coordinated them here. I have 2, the whole number 2 plus the whole number 1 equals 3 over 4/5, right? So I add the oranges together to get the 2 plus 1 equals 3. The numerators, the 1 plus 3 to get 4. And the 5 at the bottom for the denominator straight across to get 3 and 4/5, okay? So that's kind of how you should be thinking about these. If they have the same denominator, you add straight across. But what happens if those denominators are not the same? So I had students try this together today with me. Notice I have 4 3/8 on this left side minus 1 1/4 on the right side. So what I had the students do was I had them notice, look at these two bottom denominators, right? If you notice them, they're both different. However, 4 can go into 8 perfectly 2 times. And so because of that, I don't have to do much to this problem. In fact, I actually kept this 4 3/8 the same, and I brought it directly down, right? And as I bring it down, I don't touch it. But I have to do something to this right side, the 1 1/4, because it needs to equal this bottom denominator 8. So in order to do that, I know my least common multiple for them is 8, so I multiply to get there. So I do 1 1/4 times 2. So I ignore this 1 for right now. I just focus on multiplying the 1 1/4 times 2 to get 2/8, and I combine the number again to get 1 2/8. Okay, so this is my new name that I renamed this fraction to. So now my problem turned into 4 3/8 minus 1 2/8, and so then I take my whole numbers. 4 minus 1 is 3. My numerators, 3 minus 2 is 1, and 8 minus 8 in fractions is 8. So my new number is 3 1/8 for this equation. So here's another opportunity for you to practice this, and I will go over the answers with you again. We have the equation 4 1/2 plus 1 1/3. Go ahead and pause the video and then hit play for the answer and see how I got my answer. So in this equation, we have 4 1/2 and 1 1/3. On the left side, we know for both sides, because the denominators are not the same, we have to change them to the least common multiple, which we know the multiples of 2 and 3 would give us 6. And so on the left side, I multiply 1/2 by 3 to get 3/6, so that my new number is 4 3/6. And on the right side, I have 1 1/3. And if I multiply that number by 2 to get that denominator of 6, I get 1 2/6 as my new number. So when I add those straight across, 4 3/6 plus 1 2/6, I get the number 5 5/6 as my new number. So hopefully that was a little bit helpful for you on how we add and subtract fractions, just as fractions and with mixed numbers. If you have any questions, please feel free to email me. I'm happy to answer those for you. We'll talk soon. Bye.